Hello everyone, welcome to the next lecture on the PY question series. Today we will describe infimum and supremum questions related to the real analysis. Myself Dr. Harish Garg. You can simply follow my YouTube channel where there is a playlist of the CSIR NET. Here you can find the topic wise PY question series with the help of the fully shortcut tricks related to the different subjects of the mathematics and the statistics. You can see it's a linear transformation, complex analysis, sequence and series, as well as the power series. You can also see there is a PY question of the testing of hypothesis, uniform convergent, heat and wave equation, base estimator, Markov chain, and many more available in this playlist for you. So the objective is we will cover the 25 plus questions related to the infimum and supremum. We will cover the part B and part C related question from such years. We will cover all these questions with the help of shortcut tricks. So let's firstly describe you certain shortcut tricks and the concept how you can approach towards the question related to the infimum and supremum. What is the limit infimum? If you have the sequences A1, A2, A3, like these are the terms of the sequence, then you can define the supremum of each of A1, A2 and so on. Then you can define the new, that is a B2, which is after obtaining the first one, that is A2, A3 and so on. Again, how you can define the B3? You can skip the first two terms and then you can find the supremum of all these terms. Once you can find the supremum of these, now because of this supremum, this B1 must be greater than of B2. Now since B1 is the larger value than of the B2, so this sequence is my decreasing sequence. Once you have a decreasing sequence, definitely you can find the infimum of these BIs. Once you can find the infimum of these BIs, then it's called as the limit of supremum, limit superior of AN, or called as the infimum. So or we also denoted this as limit sup or limit of upper. On the other hand, if you define the limit infimum, again instead of finding the supremum, we can define as a infimum. Again we can skip the first part and so on. Now because of this infimum clearly says C1 must be greater than of C2, must be greater than of here, and because it is all are my infimum values, so you can easily find the supremum values among them. So if you, this is a supremum, that is a supremum of CIs. If you find the supremum of CIs, that would call as a lower limit or called as limit infimum, and it is denoted by here. In journal, remember that in journal this limit infimum is not equal to the limit supremum. Now the question arises is under what condition both the limits are same. So for that, the first concept is if you prove that the limit is if the sequence is my convergent. How you prove that? If you prove this limit is my L and this L must be existence as well as unique, both must be here. Remember, if you have the sequence of this, so clearly say the limits are either +1 or -1. They are existence, but it's not unique. So therefore this sequence is not convergent. If you prove that the sequence is convergent, then the limit sup and the limit inf are both same, and it must be equal to the limit of this sequence. On the other hand, if you prove that the sequence is your divergent, then the limit infimum or supremum takes the value either as infinity or minus infinity. It depending upon that whether the sequence is my increasing or decreasing. If your sequence is my oscillating sequence, then the limit infimum is not equal to the limit supremum always. For example, here this is my oscillating sequence, then you have only the two value. This is my infimum value, this is my supremum value. If you have a bounded sequence, if you prove that the sequence is my bounded, like of 1 plus 1 over n, so clearly say this is my bounded between 1 and 2, or if I consider the sequence is 1 over n, it is bounded between 0 and 1, and clearly say once you have proved a bounded, then both the limit must be exist. Whether they are equal or not, it is not guaranteed, but they are always existence. If you prove that a sequence is bounded and convergent, then both the limits are same. if you prove that the sequence is my unbounded above, or you can say it's a bounded above, then the limit supremum is infinity because of unbounded. If you prove that it's unbounded below, then we can say it's my infimum is minus infinity, as I have mentioned here. If you prove that the sequence is my increasing, then the limit of infimum must exist. That means it is not infinity or minus infinity. On the other hand, if it is a decreasing, then the supremum is again exists. Now the last concept is, if you prove that if an is my monotonically increasing and it is my bounded above, only bounded above, not the complete bounded, then the limit of the infimum is nothing but my this k. Second case, if you prove that it's a decreasing, then it is my k, then you can say this is my k is my supremum of this one. Now this is the simple way you can find, like if I simply say 1 over n, fine. So we all know this is the bounded sequence. What is that? It's a decreasing sequence. If you take the derivative is my here, which is less than 0. So once it's a decreasing, and we all know this number is my greater than or equal to 0. So what is the meaning of that? Although this is my bounded, fine. Now before I can start the PY question, you can simply join my WhatsApp group for finding such kind of the simple shortcut tricks in advance for all of you. Now look at the first question. For the sequence AIs, so we can find what is the A1, sine of pi, sine pi is 0, A2, sine of pi by 2, 1. So definitely you can see A2 is my greater than of A1. If you find the supremum of A1, A2 and so on, definitely it will be greater than of 0. So 0 will not be the answer of this. Now whether the 1 is attainable or not, clearly say A2 is my 1, so supremum is attainable and it is not the right answer. C is my right answer. Moreover, you must remember that this value lies between +1 to -1. So it means this is a bounded sequence. So this is my supremum value, this is my infimum value. Now they are talking about the supremum of this, so supremum is 1, infimum is -1. Now whenever you are solving the limit infimum and supremum, and whenever this term is present, you always break this term into the case of even and odd. So look at that. If I break this term when n is even, this term will be my positive, fine. When n is my odd, this term will be my -1 over. Then always take the limit as n approaches infinity. So what is the answer of this? It is it is e raised to power -1. When n is my even, it is my odd. Now clearly say e is my greater than of 1 over e. What does it mean? This value is my supremum, this value is my infimum. Now look at the option. He said both are same. Wrong option, because e and other is 1 over e. Again he said both are same. Again he said both are same. Supremum is e, infimum is 1 over e is my right answer of the problem. Now again it's a -1, so I can write this as even and odd. When n is even, it is my half an plus 2 over an. When n is odd, it is -half an plus 2 over an. When n is odd, this is my an plus 1. Then take the limit on the both side. So I consider this limit is my L. So you have the two limits. One is when n is odd, when n is even. So I consider the two different limit here. So what is that? Half L plus 2 over L and -half L plus 2 over L. So I can solve this. Firstly, I can solve this is half L plus 2 over L. So what is that? It's a 2L square is L square plus 2. So what is that? L is my plus minus root 2. What is that? There are the two values, plus root 2 minus root 2. This is my infimum this is my supremum. So supremum is my root 2, infimum is my cancel. Now since it's a question of the part B, only one correct option, so we can discard the other. But how? Look at that other case. When L is my, N is odd, it is my here. So if I simplify it, 2L square is minus L square minus of 2. So what is that? It's a 3L square is my minus 2, which is not possible. So that means this case is cancelled. Now limit of an is there. What is the meaning of that? It means this is my finite limit. Now they are not talking about the infimum or supremum. Fine. So how you can solve that? Clearly says this limit exists. Fine. This limit exists but not unique. Fine. So what does it mean? If limit exists but not unique, it means this sequence is my divergent sequence. So once it's a divergent sequence, the answer will be infinity or minus infinity, but not equal to root 2. Look at the last case, supremum. Now again they are not talking about the limit. So what is the A1? A1 will be 1. We can find the A2. A2, that means if I take n is my 1, we get A2. So n is 1, it's a minus 1. Minus 1 over 2, A1 plus here, so it is minus 3 over 2. We can find the A3. A3 n is 2, it's a half. It's a A2 3 over 2 plus 4 over 3. So it's a half. 9 plus 8 over 6. So 17 over 12. So its value is my 1.416. Clearly says if I found the supremum of A1, A2, A3 and so on, this value will definitely be greater than of root 2. That is, I can get at least this number. But he said is equality root 2, but it is not satisfied this condition. So this option is also cancelled. A is my right answer. Look at this another one. Again, this is there. I can take as a two cases. You can define the Bn. So what is the Bn is? Series K is my 1 to n a k. I can change them to be here as a k. It's a half minus 1 over k. Then I can take as a two cases. When okay, I can firstly little bit more calculation. I can take as a common, half is outside, k is 1, minus 1 raised to power k, minus is outside, 1 over k, k varies from 1 to n, minus 1 raised to power k. Fine. Now I can take the two cases. When n is my even, when n is my odd. So when n is my even, what is that? This term I can take n is my 2. So this term will be n is 1 to 2, that is minus 1 plus 1, cancel out. So it's a 0 minus. If I take this part, when k is equal to 1, it's a minus 1 over 1, then plus 1 over 2, minus 1 over 3, plus 1 over 4 and so on. So what is that? If I take minus as a common, 1 minus half plus 1 over 3 and so on. So do you know which series is there? This is nothing but, which series is there? This series is my log 2. Fine. So it's a minus and it's a minus. It's a plus log 2. Or you can say ln 2. You can define as a ln 2. Fine. Now when n is odd, so this if I take n is odd, I can take n is 1. So this value will becomes my minus half plus this value remains same of this. Now clearly say this value is bigger than ln 2 is bigger than minus half plus ln 2. So this value is my supremum, this value is my infimum. Now look at that. First case is limit of this. As I take the limit of Bn, it is again the same value. He said 0 is a wrong option. Limit supremum of Bn. So this is my supremum. Supremum is my, what is the ln 2? ln 2 is my 0.6 something. Okay, so but 0.6 something is greater than half is the correct option. Limit of infimum. So minus 0.5 plus 0.6 something, that's a 0.1. Fine. So 0.1 is less than of minus half is the wrong option. Again, it's a part B, so we can discard the rest of the option, but anyhow we can see this value is my 0.1, this value is my 0.6, and this value is my 0.5. Again, the last option is not satisfied. Right answer is my B is the correct answer. Always remember, student, whenever you have a minus 1 raised to power n term and the question is related to the limit infimum and supremum, always take two cases. Look at this one, a sequence of the non-negative real numbers. Then which of the following statement is my correct? Very simple. Look at that. Can you think any of the sequence whose infimum value will be 0? When infimum value will be 0? When you consider this as the sequence. Fine. So it means if I define the one sequence like 1 over n, and I have, then its limit is 0, whatever is here, then because it's a non-negative, then think about this sequence, any of n is my, say any of these even numbers are there, okay, and I can consider odd is, can you think about any term whose limit is non-zero? How you can think about the is a non-zero? If I consider this is my here, fine. So clearly say limit of infimum is my 0, it's a minimum of this, and this is the maximum. But what is the limit of xn square? Because they are not talking about the infimum, they are simply taking the limit of xn square. It's n 1 over n square, it is a whole square. So this will goes to the infinity, it is non-zero. First option is cancelled. Now again, this is also the case of the limit of infimum is 0 satisfied. Is it a bounded? It is not a bounded. Why? Because clearly say limit of xn is my infinity because of this term. So that implies this is my not bounded. This option is also cancelled out. Can you think about limit supremum? Can you think about supremum will be my 0? That is this is my infimum. Okay, I can think about here. Can you think about any of the sequence such that xn square will be my greater than 4? So definitely if I consider xn is my 2, then 2 square is not greater than 4. If I consider that my sequence is 3, 3, 3 and so on, then definitely what is the limit of infimum? Limit of infimum is my 9, which is satisfied. What is the supremum of this? What is the limit of supremum of xn? Because this is a constant sequence and it is a convergent sequence, so limit of supremum is nothing but the limit is my 3, which is my here. So clearly say 3 is not greater than 4. This option is cancelled. Only left option is my B is the right answer. Look at this another one. F is a sequence of the f is a function of bounded function. Can you consider any of the bounded function? I can simply taken as a constant. Fine, and constant must be of the natural number. So definitely it will be my say 3. I can't take as a 1 by 2 because 1 over 2 is not belongs to the n. Then which of the following is not true? If I substitute fn is here, what is that? What is the limit of supremum? Is again a 3. It is my this. So this is my correct statement. What is a constant sequence? If you have a 3, 3, 3, then limit of infimum is also 3, which is the part of natural number. It's a correct statement. Look at this one. What is the fn plus n? It is my 3 plus n. So can you find the limit of supremum or limit of infimum? So clearly say this will goes to the infinity, and infinity is not the part of n, but he said it's a part of the n. It's a false statement. He is not the part of the n is my correct statement. Which of the following is not true? C is my right answer. Look at this another one. Again the minus 1 raised to power n is given and the supremum and infimum. So we consider the two cases when n is even and n is odd. So what will happen if n is even? 3. This number becomes a positive 5 over 2n. This number becomes a positive, plus this number is positive, so 2 over n. What will happen if n is odd? This number is negative, this number is my negative, this number is my 1 by 4, and this is again negative of this. If I open this bracket, again it's a minus minus plus. Then take limit as n approaches infinity. So 3 plus 0 plus 1 over 4 plus 0, 3 plus 0 minus 1 over 4 minus plus 0. So it's a 12 plus 1, 13 over 4, it's a 11 over 4. So clearly say this is my maximum value, so this is my supremum, this is my infimum. So supremum is my 13 by 4, it's a 8, cancel, it's a cancel, 7 by 4 is a cancel, 13 by 4, 11 by 4, B is my right answer. Look at this another one. Okay, whenever you want to find the relation between the infimum and the supremum, so always say limit of an plus bn, it is always less than of limit supremum an and limit supremum bn. However, if you find the relation between the limit infimum of an plus bn, it must be greater than of limit infimum an plus limit infimum bn. Fine. So okay, if somebody asks you find the limit of supremum, say firstly negative sign. If I say limit of supremum an minus bn, it is a less than of limit supremum of an. Because of this negative, it will change to the limit of infimum. Because of this negative, it will change to the limit of here. Moreover, I will tell you a simple rule. If you want to find the limit supremum of minus 1 raised to power n of bn, that is, if it is a positive, then fine. If it is a positive, what will happen? If n is even, then it will be my limit supremum of bn. Otherwise, if it's a negative, then we can say limit infimum of bn. So I can say this value must be less than of limit supremum of bn plus limit infimum of bn. So whenever this quantity holds, we can see right here. Now look at the option. It's a supremum, so it's a less than, fine. Supremum and supremum, correct option. When it's a supremum, it's a greater than, it's a wrong option. It's an infimum, we must have a greater than sign, it's a wrong option. It's an infimum, we must have a greater than sign, and because of the positive, both must be infimum is the right answer. So this is the general formula I have mentioned you. You can remember this for the sake of simplicity. Okay, let an and bn are the two sequence of the real numbers. E and f are the subset of R. So what kind of the subset? It can be anything like 0, 1, f can be of say 3, 7 and so on. Then you can define E plus f as first element of this 0 plus 3 and 0 plus 8. Assume the right hand side of the each function is well defined. Which of the following statements are my true statement? Look at that, the first statement is my correct. Supremum less than sign by using this property. Infimum is less than sign is a wrong property because of this sign. It must be greater than. Now look at this another one. What is the infimum of E plus F? It's a bounded, so this is my minimum. What is the infimum of E? E is my 0. I need a supremum of F. What is the supremum of F is 7. So can you say 3 is equal to 0 plus 7? Not true. This option is also cancelled. If I look about this supremum of E plus F, what is the supremum of E plus F is 8, less than or equal to supremum of E1 plus 7. But this example does not give you the correct option, because examples are provided only to discard them. Okay. Now because it's a part C, it may have this is the correct option. So if I say any of the sequence of this nature, E is my here, f is my this. Fine. What is my e plus f? Because it's element wise addition, so 1 over n, 1 over m, where n and m are my any numbers. Fine. It's a sequence, it's a natural number. Fine. Then you need to find the supremum of e. What is the supremum of e? So clearly say the supremum is my 0. What is the supremum of f? Is a 0, because it's a decreasing sequence. While what is my e plus f? So clearly say if I take n and m, so both has a 1, it's a 1, otherwise 1 plus 1 over 2, or 1 over 2 plus 1, and so on. So what is the supremum of this? Clearly say the supremum will be 1. Fine, because they are limit supremum. Firstly find this 1 and then so on. So what is that? It's a 1, it's a 0 plus 0 is not satisfied. This option is cancelled. A is the only right option for this problem. Or because right hand side is my 0. Fine. So clearly say the left hand side is my non-zero. So definitely this number is my not. This option is not correct. Now look at this option. Now you can see this is the concept of limit. Okay, now it's a plus minus of this. The first part is plus bn and minus bn, and you have to apply the supremum. Fine. So what is that? This is less than of supremum an and supremum bn, but because of this less than, because of this negative, it is an and infimum of bn. Or otherwise you can see about here, this is the simple tips as I mentioned you. Fine. Limit supremum, limit infimum both. So what is that? I can return this number as limit supremum of an. I can return this number as limit supremum of an plus limit supremum of minus 1 raised to power n. Now this quantity is my less than of mod of supremum and mod of infimum. So clearly say this, this and this. Third is the right answer. Rest options are cancelled. Now whether he said may not exist, limit of supremum. If I prove this sequence is my convergent, fine, then definitely limit will be existence. So what I can do, if I say an is my 1 over n, because of this minus 1 raised to power n, I can consider this term as here. So what is my an plus of this? It is my 1 over n plus 1. What does it means? It is a convergent. If I call this is my hn, what is the limit of hn? 1, which is a unique and exist. So what is it? Is the sequence is convergent. Once the sequence is convergent, then limit supremum is same as of limit infimum, same of the limit value. But he said may not exist is the cancel out. So the right answer is only C is my correct answer. Look at this another one. If an and the bn are the two bounded sequence of the positive real numbers, so I can choose any of the two bounded sequence. So say 1 over n. Okay, supremum. Okay, we need a product also. I can simply take 2 plus or 2 minus. Fine. Or you can simply take, yes, fine. Yeah, I can simply take plus and minus are here. Then what is the an into bn? It is 4 minus 1 over n square. Now clearly say this is my bounded sequence. Fine. It's satisfied property. Also you can say it is my increasing sequence, because if you take the derivative, what is the derivative of this? It's a 1 over n square. So it is my increasing sequence. What is that? It's also the bounded sequence, plus it is my decreasing sequence. What is that? It is also the bounded sequence, and it is, what is the derivative is 2 over n cube, because n is my natural number, so it is also my increasing sequence. Fine. Now then you have to find the supremum of this. Once is a bounded, so we can find the limit of this, in which case it is, what is the limit of this? What is the n approaches infinity? Say 2, and the minimum value will be my 1, and upper value will be 2. Similarly, what is the my bn is? Bn will be, what is the value is 2 and 3. Fine, it lies between 2 and 3. You all know 1 over n is lies between 0 and 1. Fine, then if you add them 2, it's a 2 and 3, and minus 1 over n is lies between minus 1 to 0. So if I add them 2, it's a 1 and 2. What is a 1 over n square? So minus 1 over n square is again lies between minus 1 and 0. If I add them 4, it is my 3 is an, bn is less than of 4. Fine. Now look at that. First one, if an is my increasing sequence, so which one is the increasing? This is my increasing. So if I take an is my this case, supremum of a and bn. So what is the supremum of a and bn? 4 is equal to a. If an is my increasing, is a bounded above also, so it's a convergent. So this will be goes to the 2. Fine, because it's a bounded here. Then what is the supremum of b? Supremum of the b will be my, so clearly say they are not same. First option is cancel. Look at the second option. Supremum of a and 4 is less than of the 6 is satisfied. Fine, because an means an increases to the a as n approaches infinity. So it's increasing. So what is that? What is the a? A I can found as a limit n approaches infinity. So it's my 2. This is my a. So this option cancel. Now bn is my increasing, but this is my decreasing. Sorry, this is bn means bn goes to the b. Sorry, this option is, I check it, it is a decreasing. This is decreasing here. Fine. Now bn is my 2 plus 1 over n is a decreasing. So what is the by b? Is a limit n approaches infinity is my 2. So look at what is the infimum of a and bn? 3. Is it equal to, what is the limit of infimum of this is 1 into 2. They are not same, and clearly say 3 is greater than of the 2 is the right answer. So B and D are my correct options for this example. Look at this another one. What is given to you? M and N are the double array of the real numbers. Infimum of this. Firstly check out P is less than Q. P and Q. Look at that. It's an infimum. Infimum. Fine. We all know infimum is always be less than of the supremum. Fine. Then I can take the limit. Fine. Then if I again apply the limit of infimum on the both side, what will happen? Limit of infimum, limit of infimum. So this is P, this is Q. It is satisfied. Q and R. Q and R. So limit is always be greater than or equal to limit infimum. Then if I apply here as infimum and here as a supremum, it will not be greater than of this. We can't say the relation between them, so this option is cancelled out. R and S, R and S. Here you can see the supremum are same. So clearly say this number infimum is less than of the supremum by using, always remember infimum is less than of the supremum. So definitely S is less greater than of R. P and S. So what is my P and S is here. Fine, P and S. So we again know supremum is always be greater than of the infimum by using this pair. Fine. Now outside is again a supremum and infimum. If I apply the supremum on this, it must be greater than of the infimum of this. So definitely S is greater than of P is the correct answer. So A, B, A, C and D are my correct answers. Okay, look at this another one. Okay, which of the following is they are not talking about the limit of the supremum. Okay, now clearly say this is my bounded sequence, minus 1, 2 plus 1. Fine. Then what is the T? T is lies between 2 over pi to 0. So what does it means? If I multiply them, 0, t sine of 1 over t is less than of. So what does it mean? It is my bounded sequence. Fine. Once it's a bounded sequence, this give my supremum. So supremum of A is my 2 over pi. Infimum of A is my 0. Now look at the option. If infimum of A is my 0, 0 is greater than for all n. Can you say it's okay? Firstly, you can see it's a 2 over pi is less than of this satisfied. Fine. This is very simple because it's a satisfied. Infimum of A, 0 is greater than of this negative, satisfied. Supremum of A is 1 cross, infimum is minus 1 cross. A and B are my right answer. Remember, they are not talking about the limit of supremum, only the supremum of this. Okay, let Pn is the nth prime numbers in the increasing order. So that means 1, 2, prime numbers are start from the 2, 3, 5, 7, 11, 13, 17 and so on. Then define the S here. Pn plus 1 minus Pn. So the difference between them 1. Next one is 2. Next one is again 2, 4, 2, 4 and so on. Fine. Then which of the following is my correct? Okay, they are talking about the limit. Okay, what is the meaning of the infinity? How you can say that it's infinity? So as I mentioned in the earlier tips, if I prove this Sn, sequence Sn is my divergent. What does it mean? If I prove this, then it means limit supremum of Sn is my either plus infinity or minus infinity. When it will be plus infinity? If you prove the sequence is my increasing and it is my decreasing. Now you can see that this is my Sn. Fine. So clearly say this Sn sequence, that is S, is my increasing. Fine. And clearly says I can find the nth term, or you can say this sequence is my divergent. Fine. Once this sequence is my divergent, what does it mean? Limit of supremum of this Sn is my infinity. So this option is my correct option. Now as Sn is my divergent, so we can say this and limit infimum is also my infinity because both are my same. Fine. Limit infimum and limit supremum are either plus infinity or minus infinity, but we already say it's increasing. So that means limit infimum of Sn is also my infinity. So this infinity is my greater than 2, also satisfied. Now you are talking about the supremum and infimum. You can clearly say this here, this Sn is my greater than or equal to 1. What does it mean? It is bounded below. If it is bounded below, we also say it's an increasing sequence. What does it mean? It is, what does it mean? It is convergent to the infimum of the S will be my to the limit. So limit is my 1. So infimum of S is my 1. Fine. 1 is less than infinity, also fine. How you can find the supremum of the S? Now since Sn is my increasing and it is bounded below, fine. Also we can see the limit supremum of Sn is my infinity. What does it mean? Supremum of this complete S is my infinity. So this option is also correct. So that means all are my correct options. So that's a very simple target. You can achieve it in a very simple manner. Moreover, if you look about here, if you look about the first option, it is not the limit. So what is the sup of S? What is the maximum of this? What is the supremum of this? It's infinity. What is the infimum of S? What is the minimum of this? It's clearly a 1. So again, the third and the second option you can directly obtain from this, and the limit infimum is based on this divergent. Now look at this another one. For each natural number n is greater than 1, which of the following statement is my true? For each n, if I choose n is my 1, fine. So what will happen? an is n. What is the ln of 1? Is a 0. So that is my n. Fine. So an will be my of this case. Then limit of infimum is 0. Limit of infimum does not exist. No. What is the n is? N is my 1. So this is basically a 1. So what is the limit of an? It is my 1. Fine. Which is a convergent. So once is a convergent, it means limit infimum is same as of limit supremum and same is of 1. That means it exists, but he said does not exist. Limit is my 0.15. Cancel out. Only correct option which is the remaining is my D is the correct answer. Moreover, you can think about also like here, because of this term, because n is my greater than of 1, I can choose n is 10 raised to power say k. Fine. So what is my a of n? N is my 10 raised to power k. It is n log of 10 of k, greatest integer. So what is that? It's a 10 raised to power k. What is that? It is my, sorry, it's a 10. It's a 10 raised to power k. Again you can see the an will be my 1 for all case, and again in this case it's a 1. So therefore this value will be my, if you choose n is my, yes, that's fine. If you it is a simple case of this. Look at this another one. It's a June 2023. It's a sequence of the positive real numbers such that this is my x1 plus x2 and xn divided by n. This is the positive real number. Okay, whenever it's a sequence, which thing come in your mind when you see this result? It's a Cauchy first theorem on the limit. Fine. What is the Cauchy first theorem on the limit said? If xn converges to the L, then the average of this is also converges to the L. Fine. But remember, converse is not true. Fine. If average will converge of this, then this does not means of this. A very beautiful example is -1 raised to power n. Then you have to find the limit sup is the limit supremum of this. If limit of supremum is my L, that means this condition hold, then the limit supremum of the sigma, that's again the by using the Cauchy first theorem of the limit, is a correct option. Limit of supremum is L if and only if. He said converse also true, but remember he said only for the positive real sequence. This is not a positive real sequence. So what you can do, you can make a sequence which is a positive. Can you make? It's -1 and +1. I can add them as a 3. Now it's a positive real sequence. Fine. Now you have to find the supremum. Again it's a -1 to +1. So I can take n is even, it's 4. When n is odd, it is my 2. Fine. So this xn is my, what is the supremum of this? Supremum is my 4. Limit sup of xn is my 4, which is my L. Fine. Now he said limit supremum of xn is also be there. So as what is the shortcut is, how you can find the limit sup of sigma n? You can simply take the average of this always, which is my 3. So this number is my 3, this number is my 4. It means they are if and only if is not true. So that's a simple proof of this. And always remember, whatever the sequence you can take as a 13, 14, 19 and whatever. Always take the sequence of this whenever it has a average of this. If limit of supremum is okay, that is again a simple, that is nothing but my Rabi's test. So what is the Rabi's test? If I found this limit as a L, if it is a greater than 1, it's a convergent. If it is a less than 1, it's a divergent. Now you can see this is my less than 1, so series is divergent. less than 1 convergent is the wrong option. A and D, first and the last, are the correct option for this exam. Okay, look at this another one. Consider the set of the sequence X, collection of all those sequences which are either 0 or 1. So what does it mean? Xn is my sequence from 0 to 1. Always remember, students, whenever there is a question related to the countability or uncountable, fine, you always look about the cardinality. Whenever you find the cardinality, you will get the answer in a very simple manner. So look at that. X is countable. What is the cardinality of the X? Collection of this. So what is the cardinality of this? 2. Cardinality of this is n naught. So this is 2 of n naught. What is that? It is my C, which is a, what is that? Is it equivalent to the cardinality of a real number? But what is the cardinality of the real number? It's a uncountable. Fine. So it means X is my uncountable. So X is countable, X is countable, cancel out. Look at the Y. Y is a collection of all those X such that Xn will be my 1. So what is kind of this? All those natural number will goes to the only 1. So what is the cardinality of Y? So what is the cardinality of this is 1. This is my n naught, which is always pure finite here. So that means it is my countable. So once is a countable, so that means X is uncountable, Y is my uncountable, cancel, and B is my right answer. Whenever there is a question related to the countable or uncountable, always look about this cardinality. Look at this one. Again, this is a question of the cardinality, and limit supremum is there. That's why I consider this example. Look at that. X is the mapping whose supremum value will be my 1, and Xn belongs to here. That means this value. Fine. So what is the cardinality of this X? 2 raised to power n naught, which is a uncountable. Fine. So that means X is my uncountable. So X is countable, cancel. What is the Y? What is the Y? Is limit of Xn does not exist. Limit of, now they are not talking about the supremum or infimum. What does it means? It means this sequence is my divergent sequence. Fine. Now where Xn is my, so what kind of the sequence is there? You have a X1, X2, these are the elements. Fine. And X1, Xi's are either 0 or 1. So how you can check about that? You have to define the cardinality. Look at that. How many choices you have for this X1? It is either 0 or 1. So you have 2 choices for the X1. How many choices for the X2? Again you have the 2 choices. Again you have the 2 choices. So what is the total number of the choices? What is the cardinality of this? 2 raised to power cardinality of this. Again it is my here. So which is again my uncountable. So therefore Y is my also uncountable. So Y is a countable, cancel. So only last option which is pending is the right answer. A very simple, just read the statement carefully. X limit supremum is 1. So what is the cardinality of this? Cardinality of this raised to power cardinality of domain in this here. What is the meaning of the divergent? You have a sequence. How many choices of the X1? There is no restriction on the X1. Only restriction is either Xn is my either 0 or 1. So you have the 2 choices. You have the 2 choices, and so. Look at this another one. Again you have to see sup and lim. Okay, look at the first case. An. There is no minus 1 raised to power n. So there is no need. What is the limit of An? It's a 0, which is unique. So what is the meaning of that? This is my convergent. So once this is my convergent, what does it means? Limit supremum and limit infimum both are same and must be same to the limit. And you can see 0 is equal to minus 0, satisfied. Look at the second part. Now since it's so minus of 1, I can take the 2 cases. when n is even, when n is odd. So when n is even, it is my 1 over here, and when n is odd, it will be here. Then what is the limit of an? The first value is 1, other value is my minus 1. So clearly say this number is my supremum, this number is my infimum, and again it satisfied this property. Look at the C case. Again you have the two cases, because minus 1 raised to power n appears, n is even, n is odd. So it is 1 plus 1 over n, 1 minus 1 over n. If you take the limit, it's a 1 and 1. That means unique limit. So once it's a unique limit, it means limit supremum is equal to limit infimum, and this is my equal to, because it's a unique limit 1. But you can see 1 is not equal to minus 1. This option is cancelled out. An is the enumeration of all those rational number between minus 1 to plus 1. So clearly say this is my supremum limit, this is my infimum limit. Fine. I think all of you know that I can consider this is my sequence, or I can consider this is my sequence to generate these elements. So what is the limit of this? If you take the limit, it's a minus 1. If you take the limit, it is a plus 1. So this is my supremum, this is my infimum. So is it satisfied? Supremum is 1 and it is minus 1. Again, it's satisfied. So the right answers are A, B and D are the right answer for this problem. Okay, look at this another one. Which of the following is there? Define an order. Here subset E is given to be 1 over n, 1 minus 1 over n. Then infimum and the supremum. So clearly say 1 over n is my bounded, minus 1 over n is my bounded. Fine. So what does it mean? It means limit of supremum and limit of infimum exist. Fine. Now, but they are not talking about the limits. So what does it mean? If they are the bounded, we can say the supremum and infimum both exist. Fine. So look at that. He said does not exist. Cancel out. Limit, cancel out. This cancel out. So the only left option is my A. Nothing is to need to solve this problem. Moreover, how you can say? You can see this is my bounded plus it is my decreasing sequence. Fine. On the other hand, 1 minus 1 over n is also my bounded, and plus it is my increasing sequence. Fine. Now once it's a decreasing sequence, so what is the limit of this? Limit is my 0 and it is my limit is my 1. So what is the meaning of that? The supremum will be my 1 comma 0 and the infimum will be my 0 comma 1 is the right answer, because it is a bounded between 0 and 1. This number is bounded between again 0 and 1. And again you can see if this is my 0, if I take the limit infimum limit, then because of this increasing and decreasing, they have the opposite sign. Okay, look at this one. X is the collection of all those elements in there. Sin x is my greater than 0. So I can draw it graphically. It's my sine of, this is the graph of the sine. Fine. X is my minus 1. So I can write the graph as below this one also. So this is my 0. This is my pi. So pi is my 3.14. This is my pi over 2. This is my minus. This is my minus pi. So minus 3.14. Now look at that. I need a minus 1. So minus 1 is lies. This number is my minus pi over 2. So minus 1.7. So minus 1 is lies here. Fine. This is my minus 1. Plus 4. It's a 3. So it will be, this will be my 2 pi. 2 into 3.14. It's a 6 point something. So 4 will be like here. Then in this domain you have to check for which case sin x is my positive. Fine. So what is that? Sin x is positive only on this portion. Fine, this is the only portion for that. So what is the limit of this? It's a 0, it's a pi, and they are talking about s infimum, not as a limit. So s will be basically my 0 to pi. So what is the supremum of s? Is pi. Infimum of s is 0. Now look at the options. Infimum is less than 0, cancel. Supremum does not exist, cancel. Supremum is 0, and this option is cancelled. So the right option is only C is my right answer. Look at this another one. If R is the set of the real numbers, Q is the set of the rational numbers, then for this case A epsilon is my 0, 1 minus epsilon. Then which of the following statement are true? So can you find the supremum of A epsilon? Because epsilon is lies between here. So what is the minus of epsilon is? Lies between this one. So then 1 minus is of this case. Fine. So this will be the supremum of this is my here, because this number is greater than of here. Then find the supremum of 0 is less than of half of 1 minus epsilon. So what is the supremum of this? It is 1 minus, no. What is the supremum of this case? Supremum, I can apply this definition. It will be less than of supremum of 1. It's a negative sign, so I can take it as a infimum of epsilon. Fine. So what is that? It's a 1. Infimum of the epsilon is 0. So it means it is a less than or equal to 1. So equality is also be there, but he said strictly less than 1. So this is a wrong option. Second option is whenever epsilon 1 is less than epsilon 2. Okay, from here, what is the infimum of A epsilon? Infimum is my 0. So whenever this case, so what is that? Infimum of what is the infimum of A epsilon 1? 0. Infimum of A epsilon 2 is also 0. So both the values are same, but he said less than, cancel. Whenever epsilon 1 is less than epsilon 2, then now they are talking about the supremum. Supremum is my here. So what does it mean? 1 minus epsilon 1 is greater than of 1 minus epsilon 2. What is the 1 minus epsilon 2 is? Supremum of epsilon 1 is greater than of supremum of epsilon 2. So this is my correct option. Look at the last option. Supremum of A epsilon. A epsilon is my 0, 1 minus epsilon intersection Q. And right hand side is A epsilon intersection R minus Q. Fine. Now how you can solve that? It will be supremum. So clearly say it will be, how you can find that this is my 1 minus epsilon, because the supremum of this is my 1 minus epsilon and here. So how you can find that this is R minus Q. So that is basically a Q complement. So what is the supremum of this? Definitely it is my here. So both are my correct options. So C and D are my correct options for this. Clearly say you can take any of the Q. You can take any of the rational numbers, take the intersection of 1 minus epsilon, it is always the 1 minus epsilon. Look at this next one. F is my bounded function. You can take any of the bounded function. A is my real number. So answer is not dependent on A. I can take A is my 0. And you can take any of the bounded function like a constant function. Fine. Then omega is defined on A. Okay, omega is defined on A. Supremum of fx minus f of A. Then which of the following is my correct statement? So clearly says whenever, if first condition this hold, what does it means? This A minus delta 1, A plus delta 2 is the subset of A minus delta 2, A plus delta 2. Fine. Now whenever this hold, you can take the supremum of fx minus fa over this domain. is always be less than of the supremum of this domain. So what does it means? Omega of A comma delta 1 is less than of omega of A comma delta 2. So first option is the correct option. Look at the second one. Limit of delta positive is 0 for all A. Fine. It is for A. So we can consider f is my bounded function. Now you have to take fx minus fa. Okay, firstly fx, f of a I can consider as a 0. So it is my f of 0. Okay, so if I take, whenever x is my 0, that means x is my a, its answer is 0. Otherwise I can consider any of the constant function, say 1. Fine. So what is the answer of this? Is my fx only. Fine, it is my fx. Now what is the supremum? What is the w? It's a supremum. So you have to find supremum of this fx when delta is my positive. What is the supremum of this? Supremum of fx is my 1, which is not 0, because supremum of fx is my 1, but he said 0. This option is cancelled. Look at the third option. Need not exist, but this again a counter example. This is my existence, but he said need not exist. If and only if is a 0, if and only if f is continuous. So clearly say whenever fx is my continuous, what does it mean? X approaches a is my f of a. What does it mean? Fx minus f of a will goes to my 0. So what does it mean? Supremum of this number will also goes to the 0. That means omega of a comma delta will goes to the 0, and he is the correct option. So A and D are my correct answers. Look at this one. Again you are finding the limit supremum, and minus 1 raised to power n will appears when n is even. So this number is n pi plus 2e divided by 2n, otherwise n pi minus 2e over 2n. Fine. So what is that? If I take it separate, it's a pi over 2 plus e over n, otherwise pi over 2 e over n. Then take the limit as n approaches infinity, it is a pi over 2. Once this limit is my pi over 2, what is a cos pi over 2? Cos pi over 2 is my 0. E of 0 is my 1, but he said strictly less than 1. Wrong. Look at the second. Again it's a minus 1. So n is odd, n is even. When n is odd, it is n pi. N is odd, it's a negative, minus 2e over 2n, and n pi and 2e over 2n. So if you look at that, it's a pi over 2 minus e over n, and it's a pi over 2 plus e over n. So if you take the limit as n approaches infinity, it again give you pi over 2. Sin pi over 2 is 1. So it is a e. Is it e less than of pi? It's a 2.718 is less than of 3.4 is the correct answer. Look at this again. I can take this as n pi square by 2. If n is even, this number is my here, and otherwise it is a negative. Fine. So if you take limit as n approaches infinity, this part will be my 0, this part will be my pi square over 7, and this part is 0, is a pi square over 7. That is my finite answer. And log of finite answer is also finite answer. He said does not exist is the cancel out. Look at the last option. Again I can take the two cases. Even is a plus e square over 7n, and n pi square minus of this when it is odd. So what is that? If you take the limit as n approaches infinity, this value becomes my 0, and this case n will be cancelled out, pi square over 7, and this is also pi square over 7. So tan pi square 7 is my finite answer. So he said limit does not exist is the wrong answer. Correct option is only B is the right answer of the problem. Look at this another one. Look at this is the December 2022. En is a sequence of the subset of the R. This is my R. What is the subset of this? Q is the subset of R. Q complement is the subset of R, and so on. Define of this. If I consider E1 is my Q, E2 is my Q complement. The all complete is here. Then what is the union of this? So E1, E2, then okay, fine. Then what is the union of En, as n varies from K to means E1, E2, E3. Okay, I can define E3 also this, E4 also this. Even number I can define here, odd number this. What is the union of this? Can you define what is the union of this? Union of it's a Q union Q complement, that is my R. Next we need a intersection of En. What is the intersection of Q intersection? This is my phi. Clear? Then I can start from here. This value is my R. What is the intersection of this R? It is my R. What is that? Union of phi is my phi. So clearly says they are not equal. So first option is cancelled. Fine. It's a very simple elementary task. Then for some n, I assume n is my 1. So that means it is E1. Fine. I can consider E1 is my Q, and rest of them I skip. For rest of them is my Q complement, where n is greater than or equal to 2. Fine. Then again I can try for limit supremum, that is only for this part. What is the union of En, where n start from K to infinity? This is nothing but my R, because if I start from the 1, 2, 3 and so on, but it is for some n. Or if I start from En and start from the 2 to infinity, then what is that? It is my Q complement. Fine. But if I take the intersection of union of this Q, what is the intersection of this Q complement? It is my Q complement. Fine. So if I consider this is my Q complement for any x in the E, so what it means? This is my Q complement, but x is my E1. E1 is my Q. So definitely you can take any, say 3 is my Q. Fine. But 3 does not belong to the Q complement. So that means this is my false statement. Look at this one. It's again for the infinitely many n. I consider this is only for my finite n. So if you consider infinitely many n, you can consider same example 1, 3, 4, 7 and what. So you can say I can consider E of 2n plus 1, like instead of this I can say E1 is my Q, E2, E3 is my Q, E5 is my Q and so on, and the rest of them is my Q complement. So in this case what will happen, this one I can define U is my even number of this one, it is again my Q complement. What is the intersection of this one? Is again Q complement. So this part is again my Q complement. But again if I take any of the element in the Q, but it does not belong to this one, so this option is also cancelled out. X belongs to n for all but finitely many n, and this is the only left option, so that's why the right answer is my C is the correct answer. So this is the way we can solve all these limit, infimum and the supremum questions. We will see more questions on the sequences in our next lecture. Till then you can simply join my WhatsApp group, like my video and share my videos. Best of luck students. Happy learning always.